Now we have come to the last and final unit of experimental design. In this unit, we will discuss types of experimental designs. A broad yet simple way to understanding experimental designs is to categorize them into three groups: classical or true experimental, quasi-experimental, and pre-experimental designs. Within each of the three categories, there are several designs, but for the sake of simplicity, we will focus on some important ones. First, let us understand what each of these three types of designs means. Classical experimental designs always have two or more groups, and subjects are assigned to them randomly to ensure approximate equivalence of the groups. Quasi-experimental designs, on the other hand, are nearly true except that they do not exhibit some essential characteristics of true experimental designs. And pre-experimental designs do not have built-in controls for threats to internal validity. So what is a classical or true experimental design? As indicated, classical experimental design has a control group, random assignment, pre-test and post-test. For example, a researcher wants to study the impact of violent TV programs on viewers' attitude. She designs the study based on classical experimental design. She creates two groups of subjects, an experimental group and a control group, and assigns subjects to these groups randomly. She then conducts a pretest of both the groups to measure the attitude of the subjects. The experimental group then receives the treatment, that is, it watches the violent TV programs. After the treatment, both the groups receive the post-test to see whether the treatment has caused any change in the attitudes of the subjects. Depending on the situation, it is not always possible to use the classical experimental design. In such situations, researchers choose other designs which are but variations of the classical experimental design. The essential feature of a true experimental design is that the subjects are randomly assigned and there are two or more groups. An example of a true experimental design is the pre-test, post-test, control group as shown. So look at this design now. So how does the pre-test, post-test, control design look? So look at this picture here now. In this picture, R stands for random assignment, O1 and O3 are pre-test groups, X stands for treatment, and O2 and O4 are post-test course. This design has all the elements of a classical experimental design. It has an experimental group, a control group, random assignment, pre-test treatment, and the post-test. Such a design deals effectively with some common threats to internal validity. The presence of random assignment ensures that the groups formed are not different from each other in any systematic way. This helps avoid the selection bias in the experiment. It also addresses the history effect. Any external factor that may contribute to difference in the pre-test and post-test of the experimental groups would produce about the same difference in the control group. Another true experimental design is the Solomon 4-group design. If you examine the figure below, you will realize that this design is an extension of the pre-test, post-test control group design. The Solomon 4-group design overcomes a limitation of the pre-test, post-test control group design. The limitation relates to the effect of the pre-test may have on the post-test in the first experimental group. That is, the pre-test can increase the awareness of the subjects and therefore they can perform better on the post-test. The Solomon 4-group design overcomes this limitation by introducing a second experimental and control group that does not receive the pre-test. The design randomly assigns subjects to 4 groups. Thus, we have an experimental and a control group that are pre-tested and an experimental and a control group that are not pre-tested. The experiment provides information about the effect of the treatment, the effect of pre-test alone, and the randomization procedure. Let us understand this design with an example. In a study to measure the effect of watching violent television program on attitude, a researcher randomly assigns the subjects to 4 groups, 2 experimental groups and 2 control groups. 1 experimental group and 1 control group receive the pre-test. Both experimental groups receive the treatment. All 4 groups receive the post-test. If the 2 experimental groups and 2 control groups produce similar results, the researcher concludes that there is no treatment effect. In other words, the pre-test measure does not enhance the post-test performance. However, if the two groups that receive the pre-test differ in their attitude score from the two groups that did not receive pre-test, then it indicates that the pre-test has influenced the post-test. The effectiveness of experimental designs in controlling threats to internal validity is shown in the table below. So far, we have examined classical experimental research designs. Now we look at the next type of experimental design, which is called a quasi-experimental design. The word quasi means being partly or almost. The quasi-experimental designs have resemblance to classical experiments but do not exhibit some of these characteristics. For example, they may lack a control group or the process of randomization. Quasi-experimental designs are useful to explore the causal relationships in spatial situations where application of classical experiment designs is difficult or the researcher does not have full experimental control. For example, a researcher plans to administer a treatment to an entire class of students, thereby making random assignment of student subjects impossible. In other cases, a researcher may not be able to either have a control group or administer a pretest. Such situations and requirements force the researcher to use different combinations of the components of the classical design to conduct an experiment. Because these are compromise designs, the researcher should provide enough justification for their selection and state its limitations. Now we come to the pre-experimental designs, which is yet another kind of an experimental design. The single group or one group pre-test, post-test design is a pre-experimental design. This design has an experimental group, pre-test, treatment, and a post-test. It does not have a control group and there is no random assignment. This is seen in the picture below. For example, to study the effect of violent TV viewing and attitude, a researcher conducts a study on class 6 students of a school. She administers a pretest to the subjects, that is students, introduces the treatment, which is exposure to violent TV program, and observes the subjects again, which is post-test. In this design, the experiment lacks a control group as the students are not assigned randomly. That is, the entire class receives the treatment. Because this design does not have a control group, the researcher does not have complete control over the experiment. She cannot conclude whether the change in the dependent variable is due to the treatment alone and not because of any other extraneous variables. Such a design weakens the internal validity of the experiment. Now we come to yet another kind of an experimental design, which is the factorial experimental design. A factorial experimental design is very much like the previous experimental designs we have discussed. The examples and designs we have discussed so far, except the Solomon 4 group, assume that there is one independent variable. However, this need not always be the case. Often, experiments are designed with two or more independent variables. For example, a researcher may be interested in undertaking an experimental study in which she would want to examine not only the effect of violent TV viewing on attitude, but also the effect of age on attitude. In such a situation, we would have two independent variables, violent TV programs and age. Such a design warrants three hypotheses: the effect of exposure to violent TV programs on attitudes, the effect of age on attitude, and the effect of violent TV programs and age together on attitudes. The first two effects are referred to as main effects, and the third is called the interaction effect. The simplest factorial design is shown in the picture below. The first two effects are referred to as main effects, and the third is called the interaction effect as shown in the table. So thus we have come to the end of the unit on experimental designs and its different combinations and permutations. In order for you to understand experimental designs better, you read suggested books and also undertake all the assignments that have been given to you. Thank you.